Okay, class, so here is the second part of the review for the midterm. I'm going to start with question 11. It's the same PDF that you have, and I'm going to upload both this Excel sheet for you and the PDF, and I request that you please look at this carefully before you sit for the midterm, because I'm going through each question and I'm giving you ways that you can solve these successfully quickly. So I'm going to begin with question 11. Question 11 says, basically you have a chart with these test scores for 41 statistics students summarized, and these are the scores. So basically 10 students scored a 90, 18 an 80, and 13 a 70. When we have this many number of students or number of values, we tend to use this method, and this is where the Excel sheet comes in. So these numbers that you see here, and again, you will have this in your possession, this is what's given to you in the question right here. And I'm going to bold it just for the sake of bringing it to your attention. This value here is nothing more than the sum of all of the values. So basically anything that says numbers, we're adding together. So 10, 18, and 13 to give me 41. On this side of the equation, you notice that we have score, and then I have over here 900. This is simply equal to the number of students multiplied by the score each student gained. Okay, so instead of writing, for example, 10 students scored a 90, I would have to do this 10 times for the 90, the 18 times for the 80, and so on. You get my drift. I'm not going to do that because this is so much easier if you just multiply, which is what I did here. So in essence, this value, A2 times C2, is nothing more than the multiplication of these two values. If you were doing this test and they gave you different numbers here, you can change these numbers. This you can alter, not a problem, if you're using this template. This will automatically populate to give you a value. So I'm going to highlight this in a light green to indicate don't change this. And same thing for the 41 and the 3250, those are formulas. So you can change the blue cells. So go ahead and change blue cells, but don't change anything else as a reminder, okay? Because then you're gonna trip yourself up. So basically the multiplication is set here. If you click on the cell, you'll see that this is A2 times C2, this is A3 times C3, and so on, okay? This is nothing more than the sum of all of this. So if I took a calculator and I added these three numbers, I would get 3250. Your final answer for question 11 is over here. Do not change this cell. This is the division of the two yellow cells. So I'm dividing 3250 and the sum of the frequencies, which is 41. This gives me 79.26 and change. I believe that in this question they want you to round it to one decimal. Now, if you're not good at rounding, come up here and just click on this little button, and there you go. Now you have it rounded to one decimal place. Easy enough, I hope. Alright, and you do have this again for you to use, because I'm going to upload it to you. Question number 12 is a combinations question, and how many ways can 4 letters be chosen? So 4 is our R value. Remember, it's combin NR. Because order does not matter, it's a combination, and we have 1, 2, 3, 4, 5, 6, 7, 8 values. So if I double click on the 70 for question 12, you'll see that I have equals combin 8, 4. Okay, now granted, you are also able to use the formula, since we know that N is equal to 8 and R is equal to 4, we can use the formula where we have N prime over R prime times N minus R prime, which is going to equate to 8 prime over 4 prime times 8 minus 4 prime. It's a lot of writing, so I'm going to show you the long way to do this. If you use this method, you would do 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, all of this over 4 times 3 times 2 times 1, that's the bottom part, this part here, and 8 minus 4 is 4, and then again 4 prime, so we have the same thing repeated. 4 times 3 times 2 times 1. Well, common sense, we can see that this will cancel with this, so this goes away. 4 goes into 8 twice, leaving us 2 over 1. 3 goes into 6 twice, leaving us 2 over 1 on that piece. These two will cancel, and you're left with nothing on the bottom. All you're left with is basically 2 times 7 times 2 times 5. We'll do a little math here. We know that basically we have 70 here because we have, let me see, is something else canceled? Oh, that canceled, I'm sorry. So we'll end up with 70 because 2 times 5, 10, and 10 times 7, 70. Okay? Again, you have the tool that you can use, which is Combin, and I would recommend that. I'm going to stay on this PDF for a minute because this is not in your Excel sheet. This has to be done on your computer. You're going to click and shade the correct spot. And it says here, indicate Y union Z. Well, if you recall, Y union Z is everything inside the two circles, and that's what you're going to shade in. Okay, for question 14, is to suppose that A and B are independent events, such that P of A is 0.50, P of complement of B is 0.4. So here's what I did to explain this quickly and for you to be able to use this calculation easily on the Excel sheet. Here's question 14. All of this is question 14. I'm going to highlight it in a little bit of a gray to make a distinction. Alright, and what you're going to notice is I have P of A, which is given to you at 0.50, and A complement is going to be 1 minus that, so that's also 0.50. They don't give you P of B, they give you P of B complement, but we know that it has to equal 1, so this has to be 1 minus 0.4. So whatever you add these up, you'll notice that the value is 0.1. So for example, if I say equals this number plus this number, it's 1. If I come over here and I say, okay, well, this is 0.4 plus what number will give me a 1? 0.6. So that's your test. And this is why, such as in this case, where they give you the complement, they gave you B complement, which I denote with a little asterisk. So this is the same as this for me, for the sake of using the calculation. They give you that, 0.40, so we're looking for the opposite. So you would do equals 1 minus what's given to you, and you'll have your answer there. Okay? Okay, so now the two calculations. An intersection of A intersect B, so basically this times this, is calculated for you here. This is an answer. Do not change this. P of A union B is a little bit more involved. It is another calculation. And if you notice, the calculation is A13 plus A15. So basically I'm adding P of A plus P of B minus the intersection, which is 0.3, which gives me 0.8 in the end. Okay? And again, what can you change? I guess depending on what you have, I would only change those two numbers and these two numbers to match respectively. And then once you have that, as long as you have the traditional P of A, P of B here, and the complements over here, then the formula will work without a problem. And this goes back to intersection. Remember that if two values are, or two probabilities are dependent of each other, in that case, then P of A intersect B will be 0, because there is no overlap. Meaning mutually exclusive. I'm sorry, I think I misspoke there. Mutually exclusive. Okay, question 15. Look at question 15. You've got two machines, machine 1 and machine 2. They tell you that machine 1 has 531 satisfactory pistons and 59 unsatisfactory pistons. A total of pistons, meaning that if I add these two numbers, I get 590. That's your total, and I have that there for you. For machine 2, they tell you that machine 2 has 300 satisfactory pistons and 200 unsatisfactory pistons, a total of 500. What you see here in this row are the probabilities. or in this case, the percentages of each. So I took, in this case, to get 0.90, I took A21, which is the 531, and I divided it by the 590, and I did the same thing for the 59. I took 59 divided by the 590, and I got 0.1, etc. I did the same thing for the other two values. As you read the question, they're saying the probability that machine 1 has a satisfactory piston and implying multiplication that machine 2 has an unsatisfactory set of pistons. Well, what I did was I took the probabilities, and if you look here carefully, this is nothing more than the result of multiplying 0.9 times 0.4, which is your satisfactory machine 1 satisfactory piston probability and your machine 2 probability for an unsatisfactory piston, the product of which results in 0.36, and that's all you have to do. Now this is set up for this scenario. If you have the same scenario, the only numbers that you are going to change are up here. They're going to give these numbers to you. That is the only thing you change. Everything else please leave alone, because everything has been programmed for you. This also you will not change. You will leave this alone. So the only numbers you're going to change are up here. Everything else is calculated in the setup. I just realized I skipped. Let me see. Oh yeah. So here's question 16. Question 16 I'm actually going to do here on this particular spread, because that way you can see it. And what I want you to notice is, forget about all this jargon up here, all this written word. All of it is reflected here in this chart. Okay, so don't worry about all that nonsense. Focus on these numbers. So for example, I'm looking here at these two numbers right here. If this is 0.2, this is 1 minus 0.2, leaving me 0.8. In other words, think money, think a dollar. If I have 20 cents, how much am I missing to finish the dollar? I'm missing 80 cents. That's the easiest way I can explain this part. This too, you have a 0.7, this has to be a 0.3, because 1 minus 70 cents is 30 cents, right? Same thing in probability. 1 minus 0.70 gives me 0.30. This is just a reverse. They're giving you 0.70, so 1 minus 0.70, 0.30. So those are the numbers you fill in there. Now, the numbers over here, these are simply products. So you see how you have 0.8? The number next to it, 0.7. This number is 0.56, the product of those two numbers. Same thing applies this way. So you're kind of multiplying these two as such. So this will be 0.8 again, times this will be 0.3. This results in 0.24. Here's your 0.2. If I do this again, 0.2 times 0.3, this gives me 0.06. And same thing here. If I multiply 0.2 times 0.7, I get 0.14. That's what they're asking you to do. Now, the bottom part says, what is the probability that a randomly chosen voter did not vote for Hector? So not Hector is implied by the bar on top of the H. And you see that here, they tell you that. This person did not vote for Hector. So I'm looking for anything with an H bar on it on this column. So now I'm focusing here to answer this part of the question. There's only two values that have that bar on top of the H, the 0.24 and the 0.14, which when I add them up, I get my final answer of 0.38. And that is the answer that you're placing here. Okay? So it's not that difficult a question. You just have to get used to the setup and the way the question's being given to you. Okay, I did questions 17, 18, and I believe all the way through 20 on the Excel sheet to make your life a little bit easier. So let's look at number 17. If you notice here on question 17, I have appetizer, main course, dessert. These, the 9, the 7, the 10 are given to you. Do not, that's what you will change if you have to, because your numbers might be different. This will also be given to you. Those might change as well, so you could change those. The question reads, how many ways can this be done? This is where I set up the formula for you, and all you'll have to do is go ahead and change these numbers, and that'll change these numbers. So if you notice, this is formulated for you as a combination. How many ways can this be done? Order does not matter. Alright, and if you notice, same thing here, same thing here. Your final answer, do not change, is here. So by the way, don't change these either. I'm going to highlight these in a light green to indicate that these are formulas. So only change blue. Okay, I cannot stress that enough. Only change the blue cell. So don't call me in a panic if you make a mistake and you change the cell. All you have to do is go back, upload another Excel sheet, and that's it. This is the product of 126 times the 7 times the 10, and that is your final answer for number 17. How many ways? Nothing fancy there. Question 18. The urn contains 7 black and 5 pink balls. 5 balls are randomly drawn from the urn and returned. So there is replacement, and they are asking what is the probability that all of them are black. Again, this you can change. Not a problem. Blue, you can change this, because this may be different in your question. However, this, do not change, because this is actually going to be formulated, as is this. As is this. So none of these change. Leave these alone. Again, what is the result here? This is 7 divided by 12. This value here is 5 divided by 12. This value is the probability that only these, the 0.583 raised to the 5th power, because you're multiplying it times itself 5 times. Okay, and that's what that little caret represents. So in other words, if I did 0.583 times 0.583 times 0.583 times 0.583 times 0.583, that's going to give me 0.068. That's a lot of work. Alright. I'm going to go back to question 19, because it's not on the Excel sheet. The last question you have, notice I said see video of question 19. Last question I have here is actually very simple. It's just a little cumbersome to read, so I'm going to read it with you. It says, so you have a choice of vegetarian or non-vegetarian toppings for a pizza. 6 are vegetarian, 8 are non, a total of 14 toppings to choose from. So the first choice being vegetarian is 6 out of 14, but here's the thing, this is food. We don't put food back. So we're assuming without replacement. So if I go back, I'm down to 13 toppings, and out of the 6, I've already used 1, so I'm down to 5. I'm in essence multiplying these two values. So notice at the top, I wrote numerator, denominator. In numerator, I'm multiplying 6 times 5 to get 30. In denominator, I'm multiplying 14 times 13 to get 182. Both even numbers, so I divided them by 2 to see if it worked. It did. This is a prime number. I'm good. 15 out of 91, and that is your answer as a fraction. I couldn't do it on the Excel sheet because it doesn't show. Okay, but on paper, it would look as a fraction. 15 out of 91. So in essence, you're starting off with 6 out of 14 in your first selection of toppings. Once I've used my toppings, I'm down to 13 toppings, and I've already used one of these, so I'm down to 5. That's where I get the 30. 6 times 5 is 30, and 14 times 13, 182. Again, my reasoning for dividing by 2 is these are both even numbers, so I figured if I divide 30 by 2, I get 15, and this gives me 91, prime number, I'm good. Alright. Alright, number 19. Number 19 says a sample of 417 people is selected. The sample is classified, they give you the chart. They're asking you what's the relative frequency of people who do not have a college degree. Okay, no college degree is the first column. And if I were to add this up, I would have 27 plus 46 plus 46. And that's going to give me a total of 119 for this column. I know that the grand total is 417. So if I were to take 119 no college and divide it by 417, I would get 0.285 and some other decimals. They want 2 decimal places, so I need to bring this out. and I'm going to get 0.29 for my final answer. Okay? That is an overview of the questions you're going to see on your second part of your midterm. You can replay this video as many times as you wish. I wish you the best of luck.